Welcome to part 4 of the K&T vertical mill head mount video series. In this episode we're going to try and prepare the plate that will sit against the column and the dovetail pieces that clamp it to the column of the Kearney and Trecker mill. Here we're just taking a piece of, it's a 12-inch by 12-inch piece of 1-inch plate, and for some reason, I'm not sure in retrospect why, I'm cleaning up the edges, I guess in an attempt to make it look nice and workmanlike. Cleaning up the edges of the plate, and then we'll cut out a clearance spot for the spindle on the horizontal spindle, so that the mount can slide down around that horizontal spindle. This is my failed attempt at trying to bore the hole for the spindle. And as you can see from the slow motion replay, the part was able to move. I've got 2 cant twist clamps and 2 F clamps holding it down, but didn't manage to secure it very well. Here we're just trying to continue the boring. As I said, that didn't work out too well, so we had to go to plan B, which involved drilling holes and using the bandsaw to cut out the notch. That worked a lot better. The power feeds of the K&T are really nice to be able to have a feed in the Y direction as well as X and Z. Makes drilling holes really nice, kind of like a mini horizontal boring machine. So after getting the holes bored, it was time to move it over to the bandsaw. And that plate is as heavy as it looks. One of the problems with a project like this is as you start to assemble all these pieces, the weight of the thing starts to get pretty crazy. This is my little Kalamazoo, I think it's a 7x12 bandsaw, picked up off the local classifieds. Does a much better job of cutting a straight cut than the Harbor Freight 4x6 I've used for years. I've got that one just fixed in a vertical position now. Obviously the piece was too big to do the cutting all in one cut, so I had to figure out ways to move it around to get the cut made, and worked a lot quicker than that boring was going though. Once I had the side slit, I made the holes big enough that I could get the blade inside and then flip the piece 90 degrees to cut off the bottom. Worked pretty well. Sure beat using a hacksaw, or I don't have a horizontal bandsaw to throw it on to do that with. Maybe one of these days one of those will turn up and we can upgrade to that. And here's the final cut along the bottom. Kind of got the piece tilted in the bandsaw to get it to cut. Here we're switching the drill bit out for the end mill to try and clean up the bandsaw cut. And again, this is one of the advantages of having a horizontal spindle. It's, in a case like this, it's real handy to clean up something like this with the horizontal mill. Holding it so it presents a bit of a challenge, and that's the collection of angle plates is growing, because they're kind of critical to using the horizontal mill for this kind of work. I'm really hoping someday I can get used to which way's up, which way's down with the crank. Seems like whenever I start cranking, I start the wrong way and then have to go back the right way. But get there in the end, I guess. That handle there engages the X feed in the X direction. In the next video, I'll show you what happens when you engage that inadvertently. When you really want to engage the Y feed, have some interesting results. There's that's the feed speed adjustment there to adjust the feeds in inches per minute. When I initially got the mill, that wasn't working, and after pulling the knee apart a couple of times, I finally figured out that someone had dropped the Woodruff key out of one of the cams that adjusts the gearing. And fortunately, for those of you who watched Adam Booth's fix of his knee on his Kearney and Trecker, mine turned out to be far easier, and really glad it was as simple as it was, because I didn't want to start having to take any of that stuff apart in there. So here I'm just going to clean up the edges of the notch, and that notch will slide down around the spindle and the plate goes onto the column. Just a close-up of that 1-inch roughing mill. I think I should have been taking a heavier feed than that. I've since learned a little more aggressive feed can be taken with that 1-inch mill without any problem. But I tend to be a little conservative because, as an amateur, you're not quite sure what you're doing half the time. Here I'm lining up the vise to mill some aluminum square stock. I'm going to use this to make a bracket or a mount to hold the dovetails that'll be bolted onto the back of the plate, and pinch the dovetails on the back of the column. Didn't have a real good way to hold the pieces to mill I think it's a 55-degree angle that I ended up measuring on the column, and so I squared off the ends of this piece of aluminum, a square bar, and then milled a groove that would accept the pieces of hot rolled that I ended up using for the dovetail clamps. Hot roll probably wasn't a good choice, but that's what I did. Here you can see the surface finish of that face mill. Generally pretty good. Putting some, I drilled and tapped each end of the aluminum square for was a 1/2-13. Just put a transfer screw in. I saw Adam Booth using these and managed to win a couple different sizes on eBay for a reasonable amount. Super handy tools. You should keep an eye out for them. I'm surprised there's not a good knockoff being sold, but I couldn't find any when I was looking. That just transfers the location of the hole. The end plates are bolted on, and then the square was mounted up on the clamp to the table. I probably should have pulled the vise off for this, but I had it in tram so well I didn't want to mess with it. So now I'm going to go ahead and mill a groove to accept the strip of 1x2 hot rolled. It's going to make the back of the dovetail mount. Again, you can hear the run out that arbor. A little later in this video, I'll show a little something I did that worked better. It wasn't perfect, but it's a lot better than this arbor that I've got here. Just trying to adjust the feed speed to get a little better cut in the aluminum. And it does throw the aluminum pretty good. I came up with a way I'll show you here a little later to try and contain some of those chips that worked pretty good. Here's my attempt for some chip control. As you can see, it did contain some of the chips, although there were plenty on around the rest of the shop. Here's the groove that will accept the 1x2 bar stock that will make the back sides of the dovetail clamps. There's the piece of hot roll. Probably not the best choice of material. It was kind of a beast to machine, but I could get it done. Here we got both the pieces of hot rolled clamped up together using a center drill to start a hole, and then drill a couple of holes through them. Then chase it through with a larger drill. After drilling them, I then went to an end mill and milled slots in each of these pieces. I didn't get any video of that for some reason, probably because I was cursing the material as I tried to I actually burned up a couple end mills, cut and stuff. Like I said, it's mystery metal from the freight damage place. They charge 50 cents a pound for it, and you get what you get. If you're there on sale day, you can sometimes get it for half that, so it works out to be a good deal. But you do take your chances here. I'm using a little trick I saw Keith Fenner use one time, putting the oil on the hole and then blowing it into the part. I think he was doing it on one of his line boring jobs, but as you can see, it does get the oil to the cut. Seems to be pretty effective. I picked up a TG100 collet holder, a 40 taper, and some collets, using that to hold the drills, because it does give a little more room without having the chuck in the way. So I've got the piece set up now on the aluminum stand I made, and then it's tilted to the 55 degrees to get the right bevel for the dovetail. You can see the slots that were cut to give adjustment so that we can get the dovetail, give them tight on the column dovetail. Again, with the run out on the arbor, this is the point where it became unbearable, and I was forced to come up with a better alternative. The idea I had was to use the TG style collets, but the TG100 only goes to 1 inch. So I found on eBay a 40 taper TG150 collet holder, and was able to use that to make a 1 1/4 inch boring bar, which allowed me to use some of my bigger cutters. Here's the bar clamped up between centers, turned down the end for the arbor, cut some threads, made a nut, and the nut's notched to let me know which side I'd faced off to get the minimal amount of run out. Here I'm testing it. As you can see, they got it pretty good within a couple thousandths of just a couple thousandths run out on the nut. That way when it squeezes up the stack on the arbor. So there's the TG 150 collet with the rod clamped in that, and then some spacers I made and a cutter. I don't know, not a perfect solution. Here's the TG 150 collet. I'm using a strap wrench. I do have a pin wrench now that I can use to tighten it. As you can hear here, though, the cutter does a lot better job. It's running as true, I think, as you can get these big wheel cutters, but you can also see the size of cut that I'm taking here, and it worked a lot better with this bigger cutter. There's the final part cut down and ready to be clamped onto the dovetail. And that's what happens when you get the shop vac too close to the big wheel cutter. So now I'm going to try and drill and tap for the mounting bolts that will bolt those beveled pieces onto the column. So I just spot drilled or center drilled each location with the center drill, and then went through with a drill and drilled them and tapped them. I believe it was half 13 was what we ended up going with. On these again, the feeds are nice. Just set it and let it drill the hole. Sometimes without being able to back it off, when you feed manually, the chips do get a little carried away. I believe this is one of the ones that kind of got a little carried away. There's the nice chip buildup. I'm not going to say whether or not I reached in there with my hand to pull those chips off, because I know I'll get a lot of, well, I won't get any kind of negative comments. If any of the real machinists did it, they'd get an earful. But here I've just got a tap guide. Actually, it's not a tap guide, it's just a center punch holding the tap in there, so I just put one of those automatic center punches in the chuck. I'm going to use that for a tap follower. One of these days I'll break down and make myself one or buy one or something. But first I got to get a decent tap handle, because those cheap tap handles sure add a lot of aggravation to your life you don't really need. So I got the 4 holes on the right side of the column tapped. I've just got the angle plate. I bolted it on there loosely, and then I've got the angle plate up against the column with a couple of 1, 2, 3 blocks to help support things. It's one of those times when a third hand wouldn't hurt. The idea was I could kind of position it and get it in place, and then tighten those up and mark the location for the holes on the other side. This mount does limit the position of the clutch lever. You can see in the upper part of the screen that engages the spindle on the horizontal spindle. It also has the power for the Kearney and Trecker is on that arm. There's a start and a stop button. You can see we got a good fit with the dovetails on the column. And so now it's just a matter of clamping the other one on where it goes, and controlling it and tapping it, which I've since done. And here's the other side on and in place. I believe this is pretty similar to the way the Kearney and Trecker vertical heads mount on the they're the ones that they provided with the mills mount in a similar way, although they do use a drive gear that fits into the horizontal spindle to drive the vertical head, whereas the one I'm going to use has its own motor. And here's just some photos of the process of getting this part done, and that wraps up part 4 of this video series. Hopefully I can get part 5, and part 5 should put us pretty close to the end. I've decided I'll probably just do one video that kind of summarizes everything, and that way the faint of heart won't have to put up with quite so much video content. Again, thanks for watching, and let me know if you have any comments.